earliest recorded evidence tells us that man probably started life as a cave dweller, hunting for wild animals for food every day. And had it not been man's continuous endeavor to better his lifestyle, perhaps we would not have had so many of those conveniences that we take for granted available to us on a daily basis. We welcome you once again to Quest, the weekly inter-school science quiz, which tries to show you a behind-the-scenes look at how many of these things actually work. Quest is jointly produced by the National Council of Science Museums and Doordarshan Kendra, Kolkata. It's a quiz for students studying in classes 11 and 12 in Kolkata city, and it tries to provide a more educative thrust than a competitive one. Let me welcome once again Mr. Anil Manekar, who is the Director of National Science Centre, Delhi. Welcome, sir.
Thank you.
Introducing the two teams to you today. On my right, the J.C. Bose team are the boys from National High School, and you are?
I am T.S. Anantraman from National High School for Boys.
Welcome. And you?
I am Ankur Nahar from National High School for Boys.
Hi, I am Nitish Rawat. I am from National High School for Boys.
Have you been watching our show on television?
Yeah.
On a regular basis?
Yeah.
You think you're going to do well on it today?
Yes.
Yeah.
Well, let me wish you all the very best. And the girls of the C.V. Raman team are the girls from St. Thomas's Girls, Kidderpore, and you are?
Hi, I'm Shabdapani Ghosh representing St. Thomas's Girls School, Kidderpore.
I'm Amrita Mukherjee from St. Thomas's Girls School, Kidderpore.
I'm Shweta Gupta from St. Thomas's Girls School, Kidderpore.
Well, let's not waste any more time on the preliminaries. We'll be back very shortly with the very first question, which will be for the J.C. Bose team. In the first part of the show, 4 direct questions. That's 2 each to both the teams. So J.C. Bose team, the first question will come to you. You have approximately 15 seconds to answer it. If you do not answer or do not attempt to answer within those 15 seconds, we'll move over to the C.V. Raman team. C.V. Raman team, if you do not answer, we will then go into the audience. It's plus 20 on all the direct questions, there are no negative marking, and it's plus 10 on passes. Are we clear on that? Right then, J.C. Bose team. First question is for you. Mr. Manekar.
Well, friends, are you able to see a small apparatus I have brought in here? What do you see? There is a disc. Now this disc is made of which metal? It's an aluminum. Okay. Now is aluminum a magnetic material? Is it? No. It's not a magnetic material. Okay. Okay. Now the arrangement is there is a disc here which can freely rotate, and there are 2 coils placed on the 2 sides, and I have a device which will be feeding power to these coils whenever I want. Now remember, it's a DC electric supply. Okay. It's a DC supply. Fine. Now I will be performing an experiment. Let me roll this disc. Okay. It's okay. Fine. It's rotating. Now I rotate it. You see what's happening? What happens? The disc stops. Okay. Now the question is, what is really happening here? The question is, when I switch on the power to the coils, what exactly is happening?
Five seconds. J.C. Bose team not going for an answer there. I guess C.V. Raman team, it's all up to you. Girls?
The aluminum is not a magnetic material. Through the coil, induced magnetism is produced on it. So maybe that's it attracts it towards it and it stops.
Yeah, but yeah, you are on the right track, but can you add up a little more? Sure.
So how does it stop?
Yeah.
Does it stop?
Yeah, you want to add something?
No.
Come on, Shweta, you can do better than that.
Yeah.
Through the coils, magnetism is induced in aluminum, though it's not naturally a magnetic, highly magnetic material. And this, from both the sides, it's being attracted by the coils, and this stops it.
Okay. Okay. I will give you marks. The correct answer is, when the supply is given to the coils, there is a magnetic field associated with these 2 coils, but aluminum is not a magnetic material. So when the disc is stationary, nothing happens to the disc basically. But when I rotate the disc, now it is a conductor moving in the magnetic field. So, what happens? The electric, there is the induction in this field disc. All right.
Electromagnetic induction.
Electromagnetic induction takes place in this. It is called an eddy current. It is a pretty current basically. It is a small current. Now, this current also has a magnetic field of its own. Okay. So, that means there are two magnetic fields. One magnetic field due to these two coils, other magnetic field due to the current in this disc. And these two magnetic fields, they oppose each other. They oppose the basic cause of each other. And what is the basic cause? Of course, this is a stationary thing, it cannot be removed unless I switch off. So, what can be removed? The rotation of the disc, that can be stopped. So, the opposition of these two magnetic fields, that basically stop the disc, and that is the basic principle involved here.
Well, big round of applause then for the girls. Well done, girls. So 10 points then to the girls from the C.V. Raman team, and we'll be back very shortly with the next question, which is for them. Welcome back. You're watching the weekly science quiz Quest. The girls from St. Thomas's, that's the C.V. Raman team, are off to a flying start. They've got 10 points. Let's see what they do with their direct question. Mr. Manika.
You all are familiar with this, right? It is a simple normal tube light that we use in our house. It is called a fluorescent light or fluorescent tube, and you know the basic components of this, right? There is a tube. What are the other components? There is a choke inside, it is not visible because it is covered, and there is a starter which looks like this. Okay?
Also a holder, Mr. Manika?
Of course, there is a holder inside.
Yes.
And there are two holders for the tube. Okay, now I am going to switch it on. Now what I am going to do is, I am going to remove the starter. I am removing this starter, let us see what happens. I removed this, okay, but it is still on, it is glowing. Now let me switch off this tube light and then again switch on. Now it does not, okay, it is not coming on now. That means starter is now required. Let me put on starter. I have switched off. I have put on starter, and here it comes on again. Okay. So you have to explain me what exactly this starter is doing.
When the light is switched on, we need the starter because first the gas, this is a CRT. So first the gas has to be ionized,
Okay.
and then the tube light burns.
Okay.
But when the starter, we needed it only to ionize the gas. But when we do not use the starter and switch on the light, then the gas is not being ionized, and henceforth the tube light is not on. So we need the starter to start it, but afterwards the light will be glowing.
How does it? Afterwards, how the ionization remains on?
Once the gas is ionized, then it becomes conducting. So the cathode ray tube, it works, and then the light is on. Once the gas is ionized, so it can conduct it. But once it is not ionized, then it cannot conduct. Therefore, the light does not burn when we do not switch on, when we do not attach the starter at the time of starting.
Yeah, it seems you know a lot of things. Okay.
So let's have a big hand for Amrita.
What happens basically, there are two coils at the end of these tube lights, two ends, there are two coils, and these two coils are connected in series through a starter. So initially when I switch on the power, the current has to flow through one filament, through starter, through second filament, of course then the choke, and then goes back. This is the circuit of the current. Now if starter is not there, there is a break. So current cannot flow, the filaments cannot be heated, the electrons cannot be emitted, the gas cannot be ionized, and the tube light does not come on. Now when I switch it on by keeping the starter in position, everything happens, the filaments get heated, the electrons are emitted, the gas gets ionized, then that becomes the shortest path. Current later on need not flow through the wire through starter and then to the second filament. it will always take the shortest path, and the shortest path then becomes ionized gas, and that is how it keeps on glowing even if the starter is removed. Okay, good.
Well done, Amrita. You picked up 20 points for your team. Your score now moves on to 30 points. The next question will be for the JC Bose team. Boys from National High School, that's the JC Bose team. Score from your perspective is love 30. Come on, do something with the next question. Mr. Manika.
Friends, are you able to see a black box here?
Yeah.
Okay.
Not the same black box from last week, is it?
It is the same black box, but the experiment is different.
Are you very fond of black boxes, Mr. Manika? No?
Black box is a magic box after all.
Okay, let's see
So,
what
let us
this
see
one
what
contains.
magic comes out.
All right.
Let us see. Okay. So, there is a black box having 3 compartments, okay, and there is a source of light placed at one end, and there is a hole through which the light can enter in this box, okay, and it can pass through because the compartments are made out of transparent acrylics. So, light is passing from one to second to third, fine. Now, are you able to see the beam passing? Pardon?
Yes.
You can't really see the beam what is really going on, you are seeing the third chamber. Okay. Now, what I am going to do is, I have some sawdust kept in the central chamber, okay, and I am going to blow that, and this one possibly you know this, what is this one? A blower, air blower. It can blow air. I am going to blow little air in this chamber now, see what happens. Are you able to see anything in the path of the beam? What you are supposed to see is the beam becomes distinctly visible. The question is what exactly is happening here, why the beam was not visible earlier and why it becomes visible now. It's a simple thing.
So at first, when it was stagnant, when the air was stagnant inside, sand was beneath the
Stand.
It was lying beneath. The air was having no velocity. It could pass through it simply, like a pinhole camera.
Okay.
But afterwards, when air was blown, the sand it acts as an opaque body. So it's when a ray of light which is striking in the sand, it blocks the path of that light, and another ray which is not obstructed by anything, it seems as if that it is distinctly visible, and the sand.
So, what is the phenomenon known as? In one single word, you are right actually. In single word, what do we call it? Anything starting from S. It's a scattering of light. Right?
Yeah.
Anyway, you have guessed the right thing. The thing is, light itself is it visible?
No.
Light
Image
itself
is
is
visible.
not visible.
Yeah.
Okay. Light is not visible. So, what is visible? We see the particles.
Particles.
Reflected
Yes.
light is visible.
Yeah.
That's right.
So, we are seeing the particles which are deflecting light, and we are not really seeing the light.
Yeah.
Unless the light reflected from the particles enters our eye, we cannot see that. So, if you go to the space, what do you see?
Black, dark.
Why is that?
Because there are no particles.
Yeah.
There are no particles, there is no atmosphere, so everything looks black. Okay? So, that is the thing, unless there is a medium in the path of the light, we cannot see anything. Okay. So, let us give them points.
Well done, Nitesh. With that answer, you pick up 20 points for your
Thank
team.
you.
So the JC Bose team finally registering something on the board. 20 points to them. The girls of CV Raman still on 30. Next question will be for you. Welcome back. You're watching Quest. Girls from the CV Raman team. You got a lead of 10 points. Your score is 30 as opposed to 20 of the JC Bose team. Let's see what you do with the next question. Mr. Manika.
Okay. Now, I have again a simple experiment. It's easy. I'm sure all of you will know it. I have an air blower, I have a funnel, plastic funnel, and I have a simple ball which is tied with a string. Okay. Now, I would like to request Gaurav to hold it for me.
Me?
Yeah, please.
I think I'm a bit too old to play with balls, Mr. Manikar.
I think science makes old people also younger.
Okay.
Okay. Now, let me place this funnel here, and I will be holding this funnel, and I will blow air, okay, and you will have to hold it somewhat here.
Yeah.
Can you see what is happening? Okay. Actually, I am blowing air. I am not sucking air. I am blowing air. But the ball is behaving in a different way. It is not expected. The ball, we expect that the ball will be flying out, okay? But instead of that, it is really getting sucked in. So, the question is, what exactly is happening here? The ball is supposed to be flown away by the air. This is a blower, it is not a suction attachment, it is blowing air. Now, when the air is blown on this ball, it is behaving in a unexpected manner. Instead of getting away from this airflow, it is getting sucked in. So, what is the reason for this?
When the air is blown, then it is blown with a very high velocity, and we know when velocity is more, then the pressure in that zone is decreased, and as a result the surrounding air has a higher pressure than the place where the air is blown. As a result, a suction is created, because since it is a low pressure zone, so the ball is in the high pressure zone, it is pulled in and not moved, it does not move out. So, that is the reason why the ball is behaving in a different manner than expected.
And what is it called as?
The phenomena.
Yeah, the principle.
Well, it's suction. It's not. I mean,
may I give her a hint?
Bernal is principle.
Exactly on the dot.
Your favorite scientist.
Well, it's a correct answer. So let's clap for them. You know this? Exactly the same. You wanted
Well
to add
done,
anything?
Amrita, you pick up 20 points for your team. Mr. Manikar, can you add to that in any manner?
I think she has already given maximum thing.
I
This
think
is
she done
exactly the same
Full
thing.
justice to the answer?
Full justice to the answer.
Well, I guess in that case, we've got nothing more to add to that. We'll be back very shortly with the next question. Welcome back. 4 questions gone, 3 to go. The next 3 questions are on the buzzer. Both teams, please note, plus 20 if you get it right, minus 10 if you do not get it right. These do not pass to the other team, they'll go straight to the audience. Scores at this stage: CV Raman team 50 points and boys from JC Bose 20. Mr. Manikar, what do you have for us now?
Okay. Another simple experiment so that both of you can score more. Okay. I have a simple disc here made out of acrylic, okay, and I have some balloon attached to it on the top. I try to slide this disc on this table. You can see that? Okay. Why does it stop here? It is not a question basically. Okay. Friction. Now I am going to blow this balloon and then see. All right.
Yes, JC Bose team?
What your question must be why it doesn't stop, because when the air is blown inside the balloon, it is elastic, the balloon is elastic, then balloon is forced to come out of the air is forced to come out of the balloon, so it comes through the disc, so the air, there is a downward thrust by the air, so that the reaction of the air of the surface is becoming less, and we know that the friction is mu times the reaction of this, so reaction is getting less, so the product will get less, and so it goes on moving.
You are right.
Good answer. Good answer, Nitesh. You pick up 20 points. Tell me, have you ever played air hockey?
Air hockey,
Never played air hockey? Well, there are a lot of places now in Kolkata where you can play a game of air hockey, which works on somewhat the same principle, with air being expelled and objects becoming buoyant. Mr. Manikar, I think you can add somewhat to that. I think there is an industrial application which we
Yes,
yes,
yes.
there is.
This is a very important industrial application of this. This is basically a air cushion, and you know the hovercrafts,
Yes.
right? They work on this principle. They have a lot of air in, and that air is passed on to the rubber below at the bottom, and these hovercrafts can go on water as well as on the ground, because they have a layer of air at the bottom, and that reduces the friction, and that is how the objects move. Of course, they have other mechanisms to drive. So, the friction gets reduced, that is the basic principle in this, and that is the hovercraft principle. Okay.
Well done, Nitish. Narrowing the margin then, scores now read 50 points to the CV Raman team and 40 to JC Bose. Let us see what happens in the next question. Sixth question today is again on the buzzer. Mr. Manikar, what do you have for us now?
I have a simple water bottle. Okay.
Any water in it?
There is no water in it, but there is a balloon which is tied to its mouth. Okay. And possibly you know what experiment I am going to do now. I am going to blow this balloon, and let us see what happens. It is difficult. Okay. I am not able to blow it. Now the question is, why I am not able to blow this balloon?
Well, the boys once again. I think you are trigger happy and you have beaten the girls to it once again. Let us see what you say.
The main cause why the balloon does not expand easily is because there is air inside the bottle, right, and for the balloon to expand it needs some space to expand, and the pressure outside is actually contracting the expansion of the balloon and thus hinders the expansion of the balloon.
What happens if I make a hole here?
Then it will easily blow out, because as the air inside does not give any reaction force,
There's
it
no
will just
resistance.
go off and
That's
blow.
right. That's right.
Well done, Anant. With that, you have just shot ahead of the girls with 10 points lead. Now the boys from JC Bose on 60 points, girls on 50 points. Anything can happen. Stay tuned. We'll be back very shortly. Welcome back. The very final question. Anything can happen. Mr. Manikar, what do you have now?
Again a black magic.
Black magic.
Okay. I have a black surface. I have a acrylic rod which is cut into half. Okay.
And it's half circle.
Yeah. It is a half cut cylinder rather.
Half a cylinder, really.
Half a cylinder. And I have a laser pointed torch which can point a powerful beam of light. Okay. I am going to place it like this. I will hold it.
Need any help
You can
there?
see. Oh yes, thank you.
Okay, I'll hold it for you. Here we are.
Yeah. Okay. I am going to insert this beam in this rod now.
The boys have gone for it yet again. Yes, boys.
The radiation of the light, we can't see it. Your question must be this one, because because in the black surface, when it was nothing, there was no refraction, nothing. It just straight away and strike the black image, and image is formed. When it goes through this acrylic sheet, the refraction coefficient is greater than the air, so it diverges. It diverges and goes out. Rather, it making an image. So we can't see the red light.
I think we'll spare you of the agony there. Mr. Manikar's expression tells me that was not the probable question. Am I right, Mr. Manikar?
Yeah. I wish you allowed me to complete the experiment. Anyway.
I think you can ask this question to the audience, Mr. Manikar. What is your question here?
Maybe I think by the experiment itself you can understand what I am going to ask. Now what is happening inside this, the beam of light is getting in and then getting in a zigzag fashion, and it is coming out.
Do we have anyone in the audience? Yes, you want to answer? We saw you first. Why don't you come up? Yes.
ये हम लोग गेम को प्रेस करते हैं। Keep pressing.
Come here. Hold the mic. What's your name?
Well, I'm 𝐃𝐞𝐦𝐨𝐬𝐭𝐫𝐚𝐬𝐿 Xavier School.
Yes, Saikat, what do you have to say for
Well,
it?
that happens because of total internal reflection. I mean, the angle of incidence is greater than the critical angle, so total internal reflection takes place and it goes through.
What happens at critical angle?
I mean, there's no refraction, it goes through. I mean, perfect reflection takes place. I mean, the normal phenomena of reflection.
Okay. What happens at the critical angle is the beam really passes by the edge
Yeah.
of the medium.
If it's more than that, I mean, reflection.
Yeah.
Well, Saikat, you mean a lot of things. Well, even I mean something. Here's a small memento for you. Well done. Let's have a big round of applause for him. Well done. Mr. Manikar, anything to add there?
Yeah. In fact, the black surface here was just to make the beam visible, because the red becomes better visible against the black surface, and this rod is supposed to pass the beam because it's a transparent acrylic, and when I put the beam at a particular angle, the beam, instead of coming out from the sides, it keeps on bending inside and in a zigzag fashion, and it moves out. That was the question. Okay, and the question was, it's because of the total internal reflection taking place, and the angle is more than critical angle, and that's the reason.
Well, Nitesh, that response from you took away 10 points from your team. The final scores today, 50-50. Yes, that's right. Not in the literal sense. 50 points to the J.C. Bose team and 50 points to the C.V. Raman team, which brings us really to the end of today's show. I guess, boys, you will, if chivalry permits, we'll first give something to the girls. Thank you for being on our show today, Saptaparni, Amrita and Shweta. Boys, at one part of the show we were thinking that perhaps you might end up not doing as well as you did today, but well done, really. Well done. Thank you, Nitesh, Ankur and Anand. We thank you for watching. Thank you for being here today, both teams. We'll be back next week with 2 new schools, that's 6 new faces. We hope you enjoyed watching our show. Please do write in with your comments. Our address, Quest, care of Doordarshan Kendra, 18/3 Uday Shankar Sarani, Kolkata 95. We'll see you again next week with yet another show. Till then, it's goodbye from all of us.